In this section, we're looking at zeros of polynomial functions. First thing to look at is the fundamental theorem of algebra, which says that if f of x is a polynomial of degree n, where n is a positive number, then our function f has at least one zero in the complex number system. Now, what we can do is we can look at, as far as finding our rational zeros, and we'll do the rational zero test. And what that looks like is, as far as our possible rational zeros, and this is just what is possible, is we're going to take our p values divided by our q values. Now, p are the factors of our constant term, and our q are the factors of the leading coefficient. So, for example, if we have f of x is equal to 2x to the fourth minus 9x cubed minus 18x squared plus 71x minus 30. Again, we're going to look for the possible rational zeros. Which means what we're going to look at is, as far as the factors of the constant term, that would be our factors of the negative 30. And as far as our factors of our leading coefficient, that would be our factors of 2. So for factors of a negative 30, first of all, we're going to treat everything as a plus or minus. And so it would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, 6, 10, 15, and 30. Quite a few factors for 30. First, factors of 2, plus or minus 1, plus or minus 2. That just lists all of our possible rational zeros. That means we have all of these values. We also have every one of those values divided by 2 to give us all those possible rational zeros. Now, where we can narrow this down then is we can use synthetic division and we can use long division to figure out exactly what those factors are. The other thing we can do is if we use our graphing calculator and I plugged in that same f of x. Now if we go to graph, first of all, I just have this on a standard window, and so I look at the graph and it looks like this, which is kind of a mess. But I can already tell as far as those zeros go, because I'm going from negative 10 to 10, that it looks like I have a zero at about negative 3, and then somewhere in between 0 and 1. That one might be at 2, that one might be at 6. And I do know that my leading coefficient is positive, and this is x to the fourth, which tells me this graph should look like a W. I'm going to adjust the window, and I'm going to go from negative 5 to 6 just based on the zeros that I saw. And as far as my y values go, I know that this negative 30 is my y-intercept. And so maybe if I go from negative 50 to 50 and I count off every 10 units, I can look and see what that graph looks like. And it does kind of narrow down some of my zeros a little bit. Again, remember we went out to 6, so that looks like it's a 5 there. That does look like a 2. That's in between 0 and 1. Well, we have some different options over here from our possible zeros that we can look at, and then that looks like it's at negative 3. What we can then do from our graph is now we see that we have, because it was fourth degree, we were expecting a possibility of 4 zeros. It looks like all 4 of them are real, because they're all crossing the x-axis. And what we can then do is use synthetic division and start dividing. And as far as that value in between 0 and 1, if I look at these, because we can divide by 2, it looks like 1/2 is my best bet, because everything else, 2 divided by 2 is 1, 3 divided by 2, that's more than 1, and so it looks like 1/2 is a possible 0, and so that helps us narrow down our search. Of course, we could then use synthetic division or long division to prove that those are zeros and to find our factors.